Alright, let's talk about feature scaling, one of those behind-the-scenes superpowers that makes your machine learning models way better. Imagine you're building a model to predict house prices. Some features, like the number of bedrooms, range from maybe 1 to 6, but others, like the square footage, can go from a few hundred to several thousand. If you feed that raw data into an algorithm, the big numbers completely overshadow the small ones, even if the small numbers are actually more important for your prediction. That's where feature scaling comes in. It's a way to level the playing field, so every piece of information gets an equal shot at influencing your model's decisions. So, when do you need to scale your features? Mainly, whenever your algorithm is sensitive to the magnitude of your data. Think about models that use distance calculations like k-nearest neighbors or support vector machines, or anything that uses gradient descent like linear regression or neural networks. If your features are on wildly different scales, you're pretty much setting your model up for failure, or at least a lot of unnecessary struggle. And here's a key tip: always split your data into training and testing sets before scaling. Otherwise, you risk leaking information from your test data into your training data, which can mess up your results. So, fit the scaler on your training data, and then use those same parameters to scale your test data. Now let's look at the two go-to methods for feature scaling: standardization and normalization. First up, standardization. This uses something called the standard scaler. It transforms your data so each feature has a mean of 0 and a standard deviation of 1. Basically, you subtract the mean and divide by the standard deviation for each value. If your data is shaped like a bell curve, a normal or Gaussian distribution, this is the method you want. It's perfect for algorithms that expect data to be clustered around 0, like linear or logistic regression and SVMs. Second, there's normalization, often done with the min-max scaler. This method squishes all your data into a specific range, usually between 0 and 1. You subtract the minimum value and divide by the range. This keeps the original distribution of your data but puts everything on the same playing field. It's great for deep learning models and some neural networks. But heads up, it's sensitive to outliers. If you have one weirdly huge value, it can squeeze all your normal data into a tiny slice. So to wrap up, feature scaling isn't just a nice to have. It's essential if you want your machine learning models to treat all your data fairly and give you results you can trust. Next time you're prepping a dataset, don't forget to scale your features. You'll thank yourself when your model starts performing like a champ.